Welcome, Chem 9 students. We're going to have a video here. It's a little clarification, also more notes than it is clarification. So I would recommend getting this into your notes, and it's going to be very helpful for you because these symbols mean a lot for a chemical equation. Let's first start out with the first symbol that we have, the arrow symbol. That just means yields. And that distinguishes or helps us distinguish what is a reactant versus what is a product and what is being made. So this arrow, the left side is going to be our reactants, the right side is going to be our products, and so that arrow means that A and B will create AB, or will yield AB. The plus means adds together, so of course we're going to add A plus B, and it will yield AB. Let's jump down to the very bottom. There's triangle. We call that delta in chemistry. Or we just have it as a triangle. That means heat. We're going to add heat to the system to help in our reaction. Now A and B, if I put them together, they may not react immediately. We may have to give it a little bit of heat, and we have to specify that in our equation. And so we're going to put it right over that triangle. And that means we're going to add heat to the system, and now it's going to create AB. Now, let's go through these letters with parentheses. I had a great question about this in one of our discussions, and I want to clarify some stuff. Let's talk about S. S means it's going to be a solid. So whenever you see something as a solid in chemistry, it's going to be with that parentheses S next to the symbol or next to that compound. And so you can see a few things here. We can see that we have magnesium, parentheses S. That means we have solid magnesium for our reaction. For L, that means we have a liquid to work with. So, a liquid, I have hydrogen peroxide as a liquid. I'm going to break it down into H2O liquid as well. And as you can see, you can kind of guess what this G does for us too, right? It means a gas. And so G is a gas, and it's going to be created as a gas or used as a gas for our reaction. Now, last one we have is aqueous, or AQ. What that means for us, though, is that we have something being dissolved in water, or something being diluted in water. And so the best example I have for you is salt water, right? You take some salt, you're going to put it in water, you're going to stir it up, and after a while, that salt will be dissolved in water. You've just made a solution of sodium chloride. Are you going to say it's sodium chloride liquid? Well, not all of it will be sodium chloride. Are you going to say it's sodium chloride solid? Well, not really. It's not even a solid anymore. It's all dissolved. Can we say it's a gas? Well, no. Nope, not a gas. It has to be aqueous because that means sodium chloride is dissolved in water. We have some examples for you. I think it's right here. Yep. So, BaCl2. Barium chloride, also ionic, right? Barium's a metal, chlorine's a nonmetal, and it has the symbol AQ. That means we have barium chloride, we put it into water, and after a while, after stirring it, it dissolves. And now we've made a solution of barium chloride, and so we have to give it that symbol AQ. Same thing for CuSO4, right? Copper sulfate, also an ionic compound. We added that to water, we dissolved it, and now we have to give it a Q for a symbol for the phase because that represents we have a solid dissolved in water. Now those two, they create to make BaSO4, parentheses S. Okay, so that's weird, right? We see two things that are aqueous, otherwise two things that are already dissolved in water, and both of these are going to be colorless liquids or liquids with color, but they're going to be very, very clear. And so it's weird to think that we have two of these aqueous things, you put them together, and they create a solid out of them. That's chemistry for you. It's very fun stuff. You'll see that probably down the road in higher up chemistries, and it's a very, very, very fun lab. Now the next one, Cl2, right? Copper and chlorine, copper chloride, also an ionic compound, AQ. meaning dissolved in water. So that one's a hard one to deal with, but once you have it, and if you have it there, you're going to be just fine. All right. Also, don't forget dissolved in water. You can also have things that are, in this case, where is it? Right here, HCl, AQ. That means hydrochloric acid is dissolved in water or is being diluted in water, right? So you're not going to have pure hydrochloric acid. That's very dangerous. Okay. Again, don't forget about a catalyst. They speed up a reaction, but they're not chemically involved. And so just don't forget about that. Okay. Now I got one more thing to kind of specify and kind of clarify. I think it is right here. Yes. Okay. So down the road, we may have to specify what is an element versus what is a compound. And so don't forget that if it's a compound, it is being connected or bonded or attracted to another element. So NaCl, you have sodium, which is being ionically bonded to chlorine. We call that a compound. Mg by itself is an element, right? You can guess what H2O is. Also a compound. MgO, NaI, also a compound. Now what about H2, O2, Cl2, I2? That is a different story for us because they are what we call diatomic elements. What that means for us is that they exist in nature as these elements and only as these elements. You won't see a hydrogen by itself. You won't see oxygen just by itself. It has to be bonded to another oxygen. So we call these diatomic elements. And so if you go up here again and think, well, is H2 a compound or an element? It's actually an element because it exists in nature naturally as H2. This exists in nature as naturally O2, and same for Cl2 and I2. They're going to be considered diatomic, right? Dia means two in terms of the prefix, and atomic means atom, so two atomed elements. Two of the same atoms. Alrighty. If you have any questions, please let me know. This was a great video to kind of clarify some stuff, and I'll see you in the next video.